And now, a rap from Little Lane.
Uh, Yo, some and different angles are really cool, but you gotta learn the formulas to do well in school. Sine, cosine, tangent, that's what you gotta remember, but don't even stress, cause they're all really similar. For sine and cosine, you need to add and subtract, and when it comes to tangent, just divide all that. Okay guys, so for this first example, we need to take cosine of 195 and break it up into two things that are on the unit circle to use our formula here. So we're going to do cosine of 150 plus 45, because 150 plus 45 equals 195. And you can see that that's this formula here. And now we are just going to take and plug this into the formula. So it's cosine of 150 cosine 45 minus sine 150 sine 45, and then you're going to refer to your beautiful unit circle, and you can look and see that cosine of 150 is negative root 3 over 2 times root 2 over 2 minus 1/2 times root 2 over 2. And now you're going to multiply these two and then subtract. So you're going to get negative root 6 over 4 minus root 2 over 4, which is going to equal negative root 4 over 2, which simplifies to negative 1. And that is your answer.
So for this problem, the sine values and cosine values have already been given to us, and it says that they're both in quadrant 3. So I find that the easiest way to start this type of problem, which we see here as a sum problem, is by drawing two sets of axes and drawing the triangles. So since we know that they're both in quadrant 3, let's start with sine. So since sine u is negative 7 over 25, and we know that sine equals opposite over hypotenuse, we know that this is negative 7 and the hypotenuse is 25. And then for cosine, we know that since it's negative 4 over 5, and then it's in quadrant 3, since cosine is adjacent over hypotenuse, we know that it's negative 4 over 5, like this. See? And then to finish out our right triangles, we know that this one has to be negative 3, because it's a 3, 4, 5 right triangle, and since it's going down, it's negative. And that this one has to be negative 24, because it's going to the left, and this is a 7, 24, 25 special right triangle. Now we can begin our problem. So up here it says sine of u plus v. It relates to this formula up here, which is the sine u plus v equals sine u cosine v plus cosine u sine v. So we come back down here, we write down the formula, sine u cosine v plus cosine u sine v. We already know sine u because it's given to us in the problem, so all we have to do is write negative 7 over 25 times cosine v, which is already in the problem, so it's negative 4 over 5, plus cosine u, which we can then get from our triangles that we drew here. So here's our u triangle, and we know that cosine is adjacent over hypotenuse, so that the cosine u is negative 24 over 25, and that sine of v we get from this triangle, so it's opposite over hypotenuse, which is negative 3 over 5. And then, once we do that, we can multiply them together in our calculator, and you'll get here 28 over 125, plus on this side, you're going to get 72 over 125, which when you add them together, since they already have a common denominator, you'll get 100 over 125, which simplifies to 4/5, and that is your answer.
Okay guys, so for this one we're going to verify, and there's 3 things you need to remember when verifying. 1, you need to only work on one side of the equation. That is super, super important. The second thing is show all your work, don't skip any steps. And the third thing is make sure that what you get at the end of this matches this. So it's usually easier to work on the left side. So what we're gonna do is figure out which one of these equations I can plug in to make this equal this. So for cosine x plus y, I'm just gonna do cosine x cosine y minus sine x sine y, and then I'm just going to do a plus here and put it right there. And I know that cosine x minus y is equivalent to cosine x cosine y plus sine x sine y, and I'm just going to put an equals to remind me that this is this side of the equation. So basically, we're just going to combine these, and you're going to get 2 cosine x cosine y, because this and this cancel out, and when you combine that, you can get 2 cosine x cosine y, which is what we are trying to verify. And so then you can just put a little check to make sure you're done.